Show you how to test the blower in a hair dryer. This is when we were using as a blower for a hobby forge, and it overheated and melted down. So we want to see what is still good in it. This is the blower fan, and underneath the motor is there. The first question was, is it an AC or a DC motor? And obviously the whole system runs on AC, and there's not a lot of components that would change that, except hidden underneath the motor actually is more visible perhaps now. If you look right where my finger is, can you see that little bit of shiny? There's a little, actually it's not so shiny, but there's a black diode down in there. There you go, that's the diode. There are 4 of them in there, and they form a bridge rectifier circuit, which convert AC to DC, which means that you can use a cheaper DC motor. And then to turn it on, there's 2 wires that come up from underneath the black shroud, so I know that those are going to the motor. Which one's positive, which one's negative? Well, remember, at this point in the circuit, that's still going to be AC. It's only till it gets right up to the motor where that rectifier is that it gets converted to DC. So this current would be alternating anyway, so it doesn't matter which one's positive, negative, or it shouldn't. If it only works, say, in one, only works with positive up above and negative on the brown wire, then maybe the bridge rectifier is burnt. So the test will be simple. I don't know what voltage this motor runs on. It's possible they may have a resistor in there. If there's no resistor, then perhaps it operates on 120 volts DC, which seems pretty high to me, but I think that it's much lower than that, because I'll show you that a little variable transformer very much faded. It used to say 300 milliamps, which would be plenty for a small DC motor, and the highest setting is 12 volts. So with that connected, it's not a great sounding motor, but it does spin. The next thing I'll do is switch a polarity. What this will do is the bridge rectifier has 2 paths of current depending on whether the AC is in its first like polarity or its second polarity. It switches back and forth. So I just tested one condition, and I'll test the other condition and see what happens. And it also spins. Now you'll notice that the motor should spin the same direction no matter which polarity I use. And normally, if I were powering the motor directly off a DC current, if I switch the polarity, it will switch the direction of the motor. That's the last time it was spinning this way, which is counterclockwise, so let's go again. It's still counterclockwise. And again, that's because the rectifier circuit actually forces all the current to only take one path, or will go one direction through the motor, and therefore making it AC. So the motor definitely works, and because I tested both conditions, the rectifier also works. However, the motor makes a squeaky sound. I am going to cut the wires going to the heating elements and just power the motor off of these 2, which are going to be live and neutral. Open it up, now you can see the 4 diodes that form the bridge rectifier. The way it works is you can see the motor tabs kind of connect to 2 of the diodes, and then on the opposite 2 connections are where the AC current, so live and neutral, or live and neutral, doesn't matter which goes where in this case. So you can see one wire, this white one traces back to the switch, and so that is either live or neutral, and the other one goes through the heating element, which I don't want anymore. So I'll cut the brown wire and just jumper it straight back to whatever the other one, live or neutral. Blue wire, which I believe is sort of a bypass to only use half of the, it's like a half wave rectifier. Anyway, I think that's for the low setting. It would just make the motor spin less. Also do not need this yellow wire, which goes to the heating element. So now I just have one return, or let's just say the white is neutral. I haven't actually checked that yet, which one's which, but then the brown would be live, so that's also needs to be clipped. Now the heating element is, I guess it's not free, but it's free from the motor. The basic circuit will be from, say, live through the brown wire, through the motor, then to neutral, then to the on-off switch, and then to, well, I guess then to neutral. The switch, you can sort of imagine what happens inside when you're moving it. It's sort of like a jumper that connects the two positions directly under it. So in a far back position, it's called that, like, it's hidden behind that wire, but it's, say, number 1 and number 2 are connected, number 2 and number 3 are connected, or 3 and 4 are connected. Well, blue is disconnected, so that isn't going to be used for anything. So I'm just going to eliminate that guy. And then orange is going to the heater, which I already said I'm removing. So he's out. And now both position 1 and position 2 are off. And when you move it up to the top position, now it will connect the, let's say this is the neutral wire, to, it'll connect both white wires. All right. So now all I have to do would be connect the brown and the red, and we should have just a very simple motor with a switch. So I have a small wire nut. So just kind of tuck things back in. It should be in the off position, in the down, middle, but up should be turning the fan on, all right? So off, trip to breaker. So I think I found the problem. The ground wire was resting underneath the switch area. So instead of plugging it in, I'm going to use the meter on ohm setting and just see what the resistance is from live to neutral. When the switch is off, resistance should be infinite. It's an open circuit. Also, whenever the switch is down, it should, oh, so maybe I misunderstood. Oh, let me take a look at this switch again. See, there's actually a jumper between the bottom position and the top position, so that really means that the white wire is connected to the neutral either up or down. It's possible that just in that last test I damaged the bridge rectifier. It is treating as a dead short between the diodes in any configuration. You can also put it on the diode tester mode, which should tell you the forward voltage of the diode, but instead it's just beeping at me and saying 0 like a dead short. So I think that the diodes are destroyed and they're just conducting all the time. So I'll have to cut the diodes off, wire up a new bridge rectifier. So I just clipped one. The motor contact is still in pretty good shape. All right, So that's ready for fresh diodes. Going to construct this bridge rectifier is pick one of the terminals of the motor to be positive. I'll hook it up to my 12 volt power supply and see which way makes the motor spin, and then I'll mark with a Sharpie which side is positive and negative. Alright, so this is a counterclockwise spin, and this is a clockwise spin. I'll just put a mark. The way that the bridge rectifier is made is pretty simple. You want to orient two of your diodes to be with their striped side pointing towards the positive of the motor. And this is the positive because remember the negative has a black mark. So this is the positive. And that means I want both cathodes of the diode, or the side with a stripe, to be facing the positive of the motor. The two diodes, which aren't here yet, are going to go on this side, and then we will connect at this point. So I kind of want to form a square with my diodes. Now for the negative side of the motor, our two diodes go with the stripe side facing away from the motor lead. Just going to put my iron on the motor lead and apply some solder. That went alright. The next step will be to orient all the diodes and get them ready to solder to my input, my AC input wires. I'm ready to hook up the wires. At this point, it does not matter which goes where because it's alternating current. So here's the first wire. I'll attach it with as much strength as I can. So I'm ready to hook up the second wire. I think it's ready for another test. I'm going to hook my DC power supply directly up just because of how simple the circuit is. It's going straight into the motor. I mean, through the diodes, but we should see no matter which way we flip the switch, it should spin counterclockwise. Alright, so I got the switch in the off position. Move it down. And that was counterclockwise. So I feel it being blown out this side, even without the top cover. So I feel good about that. Nothing left to do but try it plugging it in. So safety glasses on again. I'm going to turn the switch on before I plug it in because I know it's going to do nothing with the switch off. I've already tested that, but also I don't want to have my hand be poking around in here while it's live. I would much rather be able to just momentarily touch it like that and see what happens. So this is live. Well, something fried, so I must have neglected some kind of current limiting resistor. I didn't see any. Oh, the heating element was the resistor. That's what it is. The heating element is supposed to be present to limit the current going to the motor, and without it, the motor gets the full current, and it was never designed to handle 120 volts, rectified DC. Rectifier off, I'm going to go straight to that motor, and it fires right up. Would have thought with all that fire coming out the back of it, it would have been toasted, but it still spins. So time to dig up an old 9 or 12 volt wall wart. Well, here's the 9 volt wall wart. The adapter is rated for 9 volts at 100 milliamp. When you check one of these wall warts with a meter, you should not be surprised when the voltage reads much higher than what it's rated for, or a little bit higher. It's supposed to be 9. How come it is 13? That's 6 volts higher. Well, it will drop down to 9 once you put a load on it, and it will even drop below 9 if you put too much load on it. What they're really saying is if you're drawing 100 milliamps, it will give you 9 volts. But if you're drawing less than that with nothing connected, it will be higher than that. And it just has to do with the way that these very simple systems are made. Well, I've identified which one is negative just by plugging it in and seeing which way makes it spin counterclockwise. Final wiring. ready for the forge again.